Hello and welcome to today's lesson. We're going to be covering topics under the Standard 3.1 in 8th grade, and we're also going to be covering topics under the Study Island Solid Figures. And in this lesson, there's just some vocabulary words you're going to need to know. You're going to need to know what a prism is, what a pyramid is, what a cylinder is, what a cone is, and once you know those vocabulary words, it's going to make this lesson a lot easier. So I would really recommend taking notes, especially on what those vocabulary words mean, and then you can study those words and make them part of your own vocabulary. And once you do that, it's going to make these problems really a piece of cake and pretty simple for you. So, and remember, as you're taking those notes, if I go too fast, you can always pause and rewind. And then you can even pause at the beginning of a question, work the problem out, and then watch the video so that you can see, oh, I got the same answer as her. And then if you didn't, you can see where you made your mistakes and you can learn about how you're doing that way also. So thank you for joining us, and let's go ahead and look at some notes.
When you have a 3D figure or a solid figure, there's 3 parts to it that you need to know. The flat pieces are called face. The seams are called edges, and then the corners are called vertexes. We give different names to different types of solid figures. So if we have a base, that could be a triangle, a square, a pentagon, or a hexagon, and then coming up from each side is a triangle that meets at a vertex, and it's a special vertex that we call an apex, then that's considered a pyramid. And then we can get more specific with the name when we talk about what kind of base it has. So if it has a triangle base, we call that a triangular pyramid. If it has a square base, that's a square pyramid. A pentagon base is a pentagonal pyramid, and so on. We can also have a prism. A prism has 2 bases that are identical that are connected by rectangles on the other side. So here is a triangular prism. So I have 2 triangles connected by rectangles on its 3 sides. A rectangular prism, I'm going to have 2 rectangles, and its 4 sides are connected by rectangles also. Now, a cube is a prism where all the sides are squares, and there's a cube. And then you can have a pentagonal prism where a pentagon's connected with 5 rectangles, and then you have your hexagonal prism also. And so once again, here's our cube. And then we have a sphere, which is like a ball. It's just one big curved space. And then we have a cone where you have a circle for its base, and then it's curved all the way around with a point at the top. And then we have a cylinder where it has 2 circles with a curved face all the way around it. This first question asks, which of the following is a geometric figure with 8 vertices, so 8 corners, 4 lateral faces? So this lateral part means 4 sides that are not bases, and then 2 congruent bases. So it's 4 sides that aren't bases, and then the 2 bases would mean that you have a total of 6 sides. So then you're going to look at each one and just count them up. So let's look. W has 1, 2, 3, 4 corners or vertices in the front. So it's going to have 4 vertices in the back for a total of 8. So it's got the 8 vertices. And then I look to see, is there 2 sides that are going to be congruent? Well, this shape here in the front is also in the back. So that would be 2 congruent bases. And then I have 1, 2, 3, 4 other splat faces, other lateral sides. So that the W has all of these characteristics. So it's most likely going to be my answer, but I want to check out my other ones just in case. Let's look at X. Here I have 1, 2, 3, 4, 5 corners in the front. So it's going to make 5 corners in the back. So that means it has 10 vertices, so it can't be X. Y is going to have 1, 2, 3, 4, 5 vertices in the front. So that means it's going to have 5 in the back for a total of 10, so it can't be y because it has 10 vertices instead of 8. And so looking at z here, it looks like it has 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm already past my 8 vertices. So it can't be z. So it is definitely W, which makes my final answer D. And these next set of questions are the ones where if you just know the vocabulary words, then you're going to be successful. So here I have a triangle on the bottom and a bunch of triangles coming up to a point, 3 actually. So this is going to be a pyramid, and it has a triangle as a base, so it's going to be a triangular based pyramid. So C is going to be my answer. Number 3 asks, what is the shape of a book? Well, if I think of a book, it kind of looks like this. And so that means I have 2 rectangles being connected by 4 rectangles along the sides. So a book is going to be a prism, which is going to make my final answer for 3C. What type of object is this one? Well, if I look, I have a hexagon on the top, a hexagon on the bottom, with 6 rectangles connecting them to. So that describes a prism. So my answer here is B. In this object, I have 2 circles being connected by a curved surface. So that describes a cylinder. Here I have 1 circle that has a curved surface going around that circle that comes to a point. So this is going to be a cone, just like a party hat. So my answer here is B. In this question here, we know the object has 4 faces, and all the faces on the object are congruent. So which figure are they thinking of here? Well, the first choice here is a cone. Well, it can't be a cone because of the curved surface. It just has the circle and the curved surface, so it could definitely not have 4 faces. Okay, a square pyramid would mean that you have a square on the bottom with a bunch of triangles coming up, and a square and triangles can't be congruent. They're not the same shape, so it can't be B. And for that same reason, it also can't be D, a triangular prism, because you're going to have 2 triangles across from each other connected by rectangles. And rectangles and triangles aren't congruent, so it can't be a triangular prism. Now, C, you're going to have a triangular pyramid. So that means you're going to have a triangle on the bottom with 3 triangles coming up to a point. So that means you're going to have 4 triangles total, so that'd be the 4 faces. And you could definitely have all 4 of those triangles be congruent, so she could be thinking of a triangular pyramid, which is C. In this object here, they want to know if you were to take this apart into different pieces, which of these 2 would you create? So the first one is a cube. These are definitely not squares here, so there's no squares in this object, so it couldn't be a cube. A rectangular prism would have 2 rectangles across from each other, all connected by rectangles. So this bottom piece here, if we just look at the bottom part of this, not this top, if you just look at the bottom, that is a rectangular prism, so it's going to be partly 2. And then a triangular pyramid, this part is a pyramid, but the base here is a rectangle, so it's not going to be a triangular pyramid, it's going to be a rectangular pyramid. So that means if I were to take the top and the bottom here and separate them, I would create a rectangular prism out of the bottom and a rectangular pyramid out of the top, which is going to make my final answer here C. So the next part here is we're going to be looking at nets and identifying what shape, if I were to cut this out and fold, I would create, which 3D shape. So when I'm looking at these are different nets for prisms. And when I'm looking at a triangular prism, that means I'm going to have the 2 triangles that are across from each other with the 3 rectangles connecting them. Just, it's laid out flat. Okay, a rectangular prism, remember you have 2 rectangles across from each other and 4 rectangles connecting them, just like you do here. A cube, you're going to have the 2 squares across from each other with 4 squares connecting them. In a hexagonal pyramid, you have the 2 hexagons across from each other. A hexagon has 6 sides, so you're going to have 6 rectangles connecting them. Okay, now we're looking at some examples of pyramid nets. This is a rectangular pyramid, so remember you're going to have that rectangle as a base, and then the rectangle has 4 sides, so it's going to have 4 triangles coming off the sides. A triangular pyramid means that you have a pyramid with a triangular base. That triangular base has 3 sides, so you're going to have 3 triangles coming off the sides. Here's some examples of cylinder and cone nets. So the cylinder net, you're going to have 2 circles across from each other, but then you're going to have a rectangle in the middle. So if you fold that rectangle, it's going to create a curved surface, kind of like a paper towel tube, and then the circles are going to close off the top and bottom. And then when you have a cone, you create a cone from half a circle and a full circle. That full circle is your base, and the half a circle is the curved edge. So those are some example nets so that we can look at some problems that deal with nets. So here they want to know which of the 4 nets shown below can be formed into a cone. Well, from those notes that you hopefully took, you saw that a cone has to have 1 whole circle and a half circle. So the only net here that has a whole circle and half a circle is W. So it's going to make my final answer B. This question here is asking which of the 4 nets can be folded into a cube. And so here it's a little bit harder because we don't have the typical 4 squares with a square on top and a square on bottom. So we have to think about how could these actually fold up. And so here, if I folded this one up, this side would come up and this side would go over here and this side would go up here, and then this one would be my top across from my bottom. But this one would go and be on the left side also, overlapping and leaving this front side open, so it can't be W. Next here, if I think about this one being my bottom, this one here would end up being my right side, this would end up being my back, this would end up being my left, this would end up being my top, but this one here would also end up being my top. So I'd have overlapping there in an open spot, so it can't be X. So Y, if I think about this one being my bottom, this one would end up being my back side, this one would end up being my left side, this one would end up being my right side if I fold it up, and this would end up being my front side, and then this would end up being my top. So if I think about how this one folds, I have all of my bases covered, so Y is going to be my correct net, which is going to make my final answer D. Now I have which of the following nets can be used to construct the figure below. So here it looks like I have a cube in the middle and then triangular pyramids on either side. So that means I'm going to have 4 squares around the middle and then 4 triangles on the top and 4 triangles on the bottom. So if I look at W right off the bat, 4 squares, 4 triangles, 4 triangles. So W's in the running. X, there's only 3 squares here. I need 4, so it can't be X. Y, 4 squares, 4 triangles, 4 triangles, so it could be Y. Z, 4 squares, only 3 triangles up here, so it can't be Z. So now I'm going to look at what's the difference between W and Y. So W, the tops here of their triangles, they're the same as in Y, as are the squares in the middle, but these triangles on the bottom, the only ones that are different is this one right here and this one right here. And if I were to fold this flat side would end up coming and touching the square. Whereas here, I would just have a corner touching the square. It would leave a gap. And there's no gaps in my figure, so it can't be Y, which is going to leave my final answer as W, which is choice A. And the last type of question you could see in this section is where you're given a 3-dimensional figure and you have to identify one of the sides if you're looking straight at it and you only see that one flat side as a 2-dimensional shape. So here you're going to want to identify the left side, so you're going to want to know that this is the left side. And if I'm looking at this from the left side, I'm going to have these 2 out front. on my right. So if I look at my rights, this one only has 1, this one only has 1, y has 2, and z has 2. So I know right away that w and x are out. And so if I look at the difference between w and z here, I'm going to continue to have 2, 1, 1, 1, 4. And then z here has 2, y has 2, and then y stops. And then but I still have a single one here. So I want to look at my picture and think, okay, when I'm looking at it from the left side, am I going to have on my right just 2, or am I going to have the 1 height and the 2 height? So if I'm looking at my object, well, here's where they're getting the 2 from, and you can see the corner of a little singlet there that would be clear on the right side if I'm looking at it from the left. So that means Z here is going to be my final answer, which is choice B. Thank you for joining us today, and I hope you learned something new.